I'm Tyler. How many of you were in the session this morning? The general, wow, okay, thank you, all right. All right, I take it since you're here, we said something that was halfway interesting to you. Prior to this session, had anybody heard of Eclipse Che before? Well, half the room, we're doing better. You know, a year ago, right, we would have gotten crickets because, you know why? Because I was at DevNation last year. There were 10 people in the room on the introduction to Eclipse Che, and no one had heard of it. It was total crickets at the time. So we've come a long ways on that. I'm going to do an overview of a bunch of things today. I'm going to introduce Eclipse Che. I'm going to do another variation on the demo that we showed this morning, only with a lot more detail. I want to get into the architecture and also get into a number of the ways that the product can be extended or applied to different environments, particularly customizations around stacks, templates, commands. There's an extension framework as well. You know, depending upon, and then on the second half, sorry, I'm going to bring up Sven here from TypeFox. He's with us, and he actually is going to show us a whole custom set of extensions and a custom language server for R and a custom assembly that they've built with Eclipse Che over the past 6 months or so as well. And so we're going to get a good overview on that. And I'm also going to then show some automation technology on how you take these workspaces and how we at CodeNV automate them into a part of a continuous delivery workflow. So I'm going to get right into it. Since I don't know where that is, can I take someone was very generous to offer an HDMI to mini adapter. Let's just get that plugged in. Okay, so essentially the story that I told this morning about having a traumatic experience with technology was absolutely true. This is a true statement. I started my career off in the 90s. I was a pure Java guy. I had written books on Java at the time. I was very skilled, and then I went away. I went into management, climbed the corporate ladder, had a pretty bad illness, and on the other side of that, I wanted to reacquire my programming skills. I sat down with Eclipse and Maven, and this technology had moved beyond me at the time, and it was overwhelming, and I did not have the tolerance or the patience or the skills to get it to work in the right way. And that was the basic idea of why can't we just give people links, and their workspaces will generate for themselves with all the dependencies associated with it. In this day and age of cloud, where we can provision anything, this should entirely be a possible scenario, right? So this basic idea is anyone, anytime can contribute to a software project without having to install the software first. This is definitely one use case of this, and this use case has tremendous benefits for children and teachers, any sort of classroom scenario. It has huge benefits with agile development, because you can associate workspaces to issues, bugs, jobs with Jenkins, and you can generate workspaces that have contextualized information attached to that particular issue at that point in time. And it also has a lot of benefits to developer bootstrapping scenarios. So if you're in a company where you have a lot of rotating contractors, or it takes a long time to onboard a new developer onto a project, or you're switching projects from time to time or doing hackathons, this on-demand nature is a big deal. There is another benefit to this as well, in that it starts to solve some of the problems between the choice and the demand of developers who want to have root control and what IT wants, which is stability as well. And we'll talk about that. So the basic idea is, what does it take to make a contribution? There are 3 things in the world that you fundamentally need. We need our IDE, we need our project files, which is our source code, and we need a runtime. And in this case here, the runtime is anything that operates against the code. It could be something as simple as a code analysis. It could be Maven. It could be your compiler. It could be the entire application that's running itself with the debugger. The point is that in order to do something with the code, you have to have an operating system, or at least a virtual operating environment, and you have to have those tools installed and that they can run. Which means that you have to have CPU, they have to be allocated storage, and there has to be memory associated with it. And so that's part of it. And if you don't have those things, just having your IDE and your project files, well, you're not going to get very far. You're going to be able to edit some things. You might get some syntax analysis out of that, but you're not going to be able to do the fundamental components. A workspace classically is defined in the NetBeans or an IntelliJ or an Eclipse world as an abstraction that lives within the IDE around your project files. And essentially, the entire purpose of a workspace, as we've understood it to date, is to apply the configuration between the editor and the underlying runtime. And it basically acts as a minified encapsulation, but it assumes that the IDE has been installed for you elsewhere, and it also assumes that whatever runtime you have is also been installed. And by default, the default runtime that is selected is usually localhost, right? Because you install your IDE, it downloads a bunch of tools, and all those tools get installed onto your localhost computer here, and that poses challenges. So if you want to move your work or share it with someone else, how do you do it, right? And historically, there's been a couple of good patterns for doing this, or at least partial patterns that various initiatives have implemented. If you're at JetBrains, they give you a configuration server so that you deploy this configuration server, and your two IDEs will synchronize its state with that configuration server. But the challenge here is that the projects aren't shared. There's certainly no sharing of the underlying dependencies. It's just basically sharing the workspace configuration. And all of the other dependencies have to be left up to the end user to get correct. A different kind of approach is the Oomph project, which is an Eclipse Foundation project. It's an open source project. And the Oomph installer is the default installer for Eclipse IDE today. And what it includes is there's a server, and a user will come along and say, I would like to get an Oomph profile. And inside that profile would be the definition of the IDE and the workspace to download and install. And so you get that profile, and it has enough intelligence so that it actually drags all that stuff down and installs it locally. But once again, your underlying runtime is bound to the computer that it installs itself on. So it dramatically simplifies the installation and setup of new profiles, but still the dependency is there. And then you also have the Flex project, which essentially takes a messaging bus and bridges it between two completely different IDEs or tools, and it synchronizes their state back and forth on that. But it's completely unaware of the underlying system that's there. So these are tactics that have been there to share the workspace in the past. But none of these address the fundamental issue, which is how do you share the runtime? This runtime issue is particularly challenging in an enterprise scenario. And I would assume that since this is Red Hat DevNation, is there anybody in here that's not somehow enterprise? I mean, mostly enterprise or academic, university. We're all in that sort of world. And so there is this fundamental tension that exists in the world. When developers are developing, we're doing it in a development runtime. And the moment we use the word runtime, we set up the issue of who has root access. It's just a fundamental issue. And when developers say, I will develop on my laptop, essentially what we're saying is that I have root control of my development runtime. And when IT steps in and says, no, 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 I'm going to give you a server or a VM or whatever that thing is, they are saying we will control root access. And whoever has control over root access can then limit the choice that's there. And it puts IT into this horrible position. Because if you haven't read Stephen O'Grady's book, what we've seen over the past 10 years is that developers are in control. They have a lot of power over the direction and the influence of the company. And what developers expect is they want choice over their programming languages and processes and frameworks. They want speed. They want instantaneous access. And what IT wants is stability. They just want things to be stable. And so when IT takes control of that server and they will start to restrict root access, what they're really doing is they're forcing a choice. And the choice that they're forcing is that, look, Mr. Developer, you can give up the languages that you want. You can give up the control that you demand and use the languages and frameworks that I'm stating as the standard. And this is horrible for IT because the ultimate impact for them is that they're likely to reduce their retention rates of talent. Because ultimately, developers will look at this and say, this is just fundamentally what I just don't want to do. And if they allow developers to keep root access on their own machines out there. The developers have total choice, and they can choose their languages and their frameworks and whatnot, but ultimately it introduces instability into the production cycle. So it's an impossible choice, and it's not the developers who have to make that choice, it's IT. So does IT move off of stable languages like Java at a cost of billions in years? You know, do they let it go? What do they do? So it's a problem for them. So, you know, but at the same time as developers, even though we have root access control, localhost has its limitations. You know, you can't exactly share it. You can't scale localhost here. You know, you do have control, but you can't give it to admins in that regard. So, you know, the approach of Che, and fundamentally Eclipse Che, is a project around this concept of workspaces. And we said, look, let's redefine the workspace so that the encapsulation is different and that it's inclusive of everything that is not just the project code and the IDE, but all of its dependencies as well. So we'll just run through this. So first thing at the core, a workspace brings its own runtime. We call this runtime a machine inside of Che. Che implements different kinds of machines. Now, the default machine implementation is Docker. So that when your workspace says, give me a machine, it goes off to Docker and it provisions the machine. Your workspace can have multiple machines inside of it. There's no limitation to this. The only limitation is the amount of memory that you have available to it. You know, so you can have, for example, a Vagrant machine here. You could have an SSH machine. Our default is Docker. And Docker is very important to us, and we started working with Docker in 2013 because it is one of the few runtimes that is completely descriptive. And that we can use Dockerfiles as a form of recipe to describe the contents of the machine that will go in the workspace. And because we can describe them that way, it allows us to grab elements of those recipes and in turn give them back to the developer so that the developer in their user interface can take control over the definition of what goes into their workspace without having to worry about the operational details of the runtime itself. So it allows us to create this separation between what is the control that the developer has and the control that the system needs to maintain. Projects here, traditional classic projects, which is your source tree. And the source tree, each project can be mapped to one repository. And these repositories could be Subversion or Perforce or Git and whatnot. And after the runtimes have been activated, these projects are mounted in. And it's a file mount. Now, if you were doing Docker on the command line, this would be a volume mount. If you use CodeEnvy, which is, I'll talk about that in a minute, a distributed version of Che, we do an rsync from long-term storage in. So the projects and the runtimes are completely kept separate until the workspace is said, let's go live, let's turn ourselves on, and then they're married together. They're married together in that way. Then, inside the workspace itself, the workspace is now a server. It's its own server, and it is able to host up an IDE, right? And we put technology inside the workspace to allow us to serve up certain RESTful services, and other technology, and we have a browser IDE that we've built. And this browser IDE, it follows an architectural pattern that's very similar to the Eclipse IDE, which is a series of extensions and plugins that in combination together create this visual experience. And you can take these plugins out, you can add in your own plugins, you can customize it to change the look and feel. These extensions and plugins are built in Java, and then we transpile them into a cross-browser optimized JavaScript package, and then that JavaScript package is hosted either on the Che server or within the workspace so that the client can gain access to it. In addition to that, inside the runtime, we set up a secure shell daemon so that every workspace has its own IP address, its own port, and its own set of credentials, so that if you want to use IntelliJ or whatever your favorite tool is, Sublime, Emacs, you can SSH mount into the workspace and have direct access to the projects, and then configure those projects within your tool of choice on that. So we don't go around, you won't hear the Che team talking about how we really think about ourselves as an IDE all the time. We do use some very aggressive positioning like as a next-gen Eclipse IDE because it gets everybody to come into the room and say, what did you say? Did you say an IDE? Everybody's like, I want to see what the next IDE is. But primarily, the browser IDE that we provide is there for people who don't want to bother installing something. Because if you access the workspace and you don't have a tool installed, you can just use the browser and get to it. But if you want to have a more permanent solution, you could have a desktop IDE. And ultimately, this configuration here is what Vagrant was trying to achieve, but there's without all the overhead and all the manual setup. Because what Vagrant does is they have the huge VM. You've got the big underlying OS stack. You got to find a way to then cross-mount your projects in, but there's all this difficulty between host and non-host mounting. And then you have to configure your IDE in. So it's essentially the same configuration, but with the runtimes inside the workspace. The Che server itself is running outside the workspaces, right? So the purpose of the Che server is to act as a workspace manager. You can create workspaces, you can remove them, you can update the workspaces, destroy them, and it hosts it there. And you can put as many workspaces on a single server as you can based upon the resource limitations that are available to you on that. And ultimately, this server is where you can start drawing that line where IT operations has access to the right administrative and operational controls, such as resource management, backup and recovery, dealing with LDAP integration, apart from the developer's abstraction, which is what he cares about, is root access to the runtime so he can install his utilities, he can configure them, and he can write his applications. The IDE itself is built on JDT, which is the Java Intelligence Services, and we've taken the JDT and wrapped it into a language server with a RESTful protocol on it. And so whenever you do a Java project, inside of that workspace itself, we install a bunch of extra software, and it's all the same software that you would have had if you had installed IntelliJ or Eclipse on your desktop, and then it runs locally inside the runtime there on local host speeds, and then we just have a lot of elegant RESTful wrappers around it, and those RESTful wrappers allow the browser to act as a thin, dumb client with a high-performance UI connecting back over HTTP and WebSockets back into the workspace itself. This allows us to make workspaces shareable. You can put 2 users into a workspace at the same time, right? It's just a shared system in that regard. And it also makes them portable. And you can port them in a number of different ways, because the entire workspace definition is described in a JSON format. And what is the workspace here? Well, it's a list of projects that are in a set of repos that have a particular tag or a label. It is a set of runtimes, which are defined by Dockerfiles or compose files, which once we commit the compose code in there. And those files, we can then build the images on demand, or those images could be hosted in a registry. And then there's a set of meta information that goes with it, like what's the project type of those projects, do you auto snapshot and whatnot. And so if you want to move a workspace from one location to another, it's a rather simple process in that you just need to be able to get the source code from one location to the next, because the source code is mounted in. And so that could be a shared Git repo or a local one that you move it to from the shared one. And then you have to get the state of the runtime as well. And so the way that we do this is that you can snapshot the workspace, right? Because because of Docker, these are Docker containers. And so if you snapshot the workspace, we go through each of the runtimes that are there, convert them to an image with their interior state, put those images either on disk or into a registry, and then make those images available to be reconstituted when you want to run the workspace the next time. So that stuff could live in one location on a computer. You could move it to another, and it will reconstitute in exactly the same state that it was when it was offline. And because we're engineers and just geeks, and we want to program all this stuff. So the Che server itself has a RESTful API, and in fact, there's Swagger that's built into the Che server. If you just launch your own Che server and then do /swagger at the end of the root there, you'll get a list of all the APIs. And everything that the IDE does, or that our browser experience here does, is controlled through the API. So you could completely throw away our clients and create your own IDE experience or your own control framework on that. And then each workspace as well. So for every workspace that you create, we put inside of the RESTful server its own API set, and you can get direct access to that. And so you can actually write plugins and extensions that deploy into each workspace. You can have custom APIs there so that you have tools that are different for each workspace one at a time. So when all this comes together, it comes together in this architecture graphic, right? I think of Che, I try to describe Che as a tripod, right? And what I mean by the tripod is that you've got the browser or the client, the server, and the workspace, and they all need to be in communication with each other all the time. And when you're starting that workspace up, what you're doing is they're navigating the protocol to one another for you. So lots of interesting details here. So here we go. Great. OK. So what I'm going to do, got Eclipse Che up. All right. So is that readable in the back? Want to go bigger? Better? Thumbs up. OK, great. OK, so a stack here is just an abstraction around defining a set of runtimes. So we're going to create a workspace. I need to select the source code. I'm going to use a template here, but I could import from Git or Subversion or Zip if we wanted to. But I'm just going to use a template. I'm going to take the Java stack. We've got a stack library, and we're working on making this integrated so that your stacks can be automatically shared with others, and you can see stacks that are available here. But these stacks are just JSON objects, and they're JSON objects that basically reference, which Docker file do I want to use, what's the contents of that Docker file, or maybe it's some image. And earlier today, I showed you can write your own stack, and the write your own stack is, hey, just come in here, paste some Docker file, and we'll honor that here for your runtime. But I'm going to use the Java stack. This Java stack has JDK8, it has Maven and Subversion and Git. This is Ubuntu, which is, it's RHEL-like. I forgot that where I'm at today. Give myself a few gigabytes of RAM here, not too much. And I'm going to give myself, use a Java Spring web application, and I'll create the project there. So it goes through a 4-step process. So the first step is, let's just create the workspace, OK? Register the workspace object. Let's save it in storage. The next step is, OK, create all the runtimes that are necessary. Now, you saw that that was really fast. And so creating the runtimes is, hey, I'm going to create the container for it. Now, if I had given it a Docker file, it would actually then first build the Docker file into an image, if it hadn't already done that. And if it was referencing an image, it would then go to Docker Hub and download any base images that were there. In this particular case, I've done this demo before. I've got the image cached locally, and it was up and running. After the container has been started, we then mount a mini Che inside of it. We put a mini Che inside of the container itself. And so that's another server that boots up. And that green output that we saw there was the starting of what we call the Workspace Agent. And those error messages are fine. That was by design. And what you see here is that this is a Tomcat booting. And inside that Tomcat, we've got a bunch of agents that we deploy. And those agents are going to provide all the development Intellisense and intelligence capabilities that we need. So whenever we access the files for the project, whenever we do Intellisense work, all the communications back to the browser and all the communications back to the Che server is coordinated through this agent that's running inside the workspace itself. And the process that it goes through is it gets itself online. After it gets itself online, it then basically is pinging the Che server, because the workspace and the server may not be on the same machine, so it needs to verify that there's got a valid connection back and forth. And once all that stuff is done, it says, great, now I need to get the project in there. In this particular case, it was a Git clone from a GitHub repository. It did the Git clone activity, and it said, great, you're all said and done. You can now open the IDE. So once the workspace is running, it's running, right? it's a server there. I don't have to shut off the server. I can just leave this there. Up on the top, I've got a URL. That URL is a sticky URL, and there's multiple flavors of this. But every workspace has a unique ID, and you can do /workspace, and there's a namespace pattern to it, and you can just put it in here, and it'll load up. The JavaScript for the IDE is just a couple of megabytes, and once you've got it there, each tab that you have open is approximately 90 megabytes of RAM. So I could have 50 workspaces running, and each one of them would take about 90 megabytes of RAM on my local machine here. The experience itself is intended to be as close to localhost speed as humanly possible, because everything that you need to do against the code is running inside the container. So as long as that container is on a machine that doesn't have thrashing with the disk and enough RAM, it's going to run at the same performance as if you had it on your desktop here. And we've got a web terminal that we've installed into the shell, or the container, I'm sorry. So we add this web terminal as well. Let's see. I can go to Web Java Spring. Here, I can run Midnight Commander on this, which is a full Linux capability. All right. And I can have more terminals if I wanted on this. I could launch these terminals into a custom window, so I have access to it. And if I wanted to SSH mount, you just click the SSH button here, and here's the PuTTY instructions on how you would either connect with Windows or the SSH instructions to connect with Linux to get you into your workspace on here. Okay. Let's get this here. I'm a little bit behind schedule for Sven. It's okay. Go fast. So close that out. So here's a Java class. The Intellisense is context sensitive, right? So it's actually running the actual JDT on the back end for Java 8. I put it inside the method, and I got one capability. I put it outside the class, and I get a different capability. I would type import org dot, put it here, and I get that. I get a different capability. I get a warning here. And you can see that it's moving pretty fast. I can do Alt-Enter. I can remove these unused imports. And it's pretty darn fast here. I can even come along, do like request. I can do Shift F6 twice. And if I wanted to, I could rename that local variable. Or if I wanted to do something even more devious, I could, give me a good, I don't have a good, here we go. Shift F6. Oh, not that one. Shift F6 twice. View 2. Get a preview on this. And it gives you a side-by-side comparison of the refactoring that you're about to do on this. So I could actually do full-on refactoring. And since I'm running out of time, I typically go through, create a bunch of classes, and I can refactor them. And you'll see that they're refactored on the disk, on the remote server. They're refactored in the editor, refactored in the tabs, and it's all completely updated and maintained in sync for you on that. What's next is that we have this concept of commands. And so a command is an approach to simplify the execution of common repetitive tasks. You're dealing with a runtime, and that runtime allows you to run commands in there. And so a command is something you define in your workspace yourself, but then we take that command, and based upon the type of that command, we will translate it into a process to be executed, and then inject that process using Docker exec into your runtimes that are there. And so this command is essentially saying it's a Maven command, which means that we're going to run the Maven utility on it. The command line itself is clean install, and then afterwards we're going to do a copy and move some stuff around. And here's the directory that you want to run that command in, and then you're going to give yourself a preview URL, which in this case is if it's a server, we need to know what the IP address and port number and prefix URL of that server is going to be once the command is done. And so that macro allows us to devise this, and that's the IP address of my server and the port name of where this server is running. And it looks like it's up and running already, and I click that, What did I do wrong? Let's run. Oh, I did the wrong one. Let's stop that. There we go. Build run. Maven clean install. The Warfare. Good. It looks like it's got to do some Maven downloading. So this is Sven Eftinga.
Right.
Yes.
Very nice.
All right. I got that right. He's with TypeFox. And TypeFox has been working with Che for a while, and they've been building a custom R plugin and custom assembly for that. And so he's going to walk through the language server protocol and the work that they've done in collaboration with us for about 20 minutes.
All right. Yeah, so I'm actually CEO of TypeFox, a German company. And we focus on building tools. Like we build products for bigger companies and startups that are kind of software tools for engineers. We used to do that mostly like desktop apps based on Eclipse RCP or IntelliJ IDEA plugins, these kind of things. But you know, the cool stuff is going on in the cloud now, and Eclipse Che is a very nice framework to do that. So I want to share our experience we made with extending Che. So it's like the workspace server is there, the cloud IDE, you just saw that, and what you kind of didn't learn so far so much about is that it's really a very good platform for building products that are hosted in the cloud, right? And we did that for one client, a startup from San Francisco, for which we build a data scientist cloud IDE. And so we have this tripod again. This is their Che architecture. I called this workspace server. That's the Che server, the main server on top. And then we have the browser client on the left-hand side. And then we have the IDE server, the server in the workspace that serves the kind of the tooling, right? And if you want to add language support to Che, then these two processes, so to say, are the main extension points. For the one in the middle, we, of course, defined a stack for the RR IDE. And I'll show you that in a demo. I think that's better. All right. So let me zoom out a bit. So the first thing we did, of course, and that's really a cool thing for, especially in R IDE. Who knows R, the programming language? Just a few of you. It's a very kind of, it's a standard for data scientists, so to say. Well, it's really used for data analysis, statistics, and so on. And it's a kind of a Linux tool that has a lot of dependencies with other like compiler like C compiler and so on. So it's really kind of hard for people who are not programmers kind of install, get the right versions done. And I mean, we have good package managers, but it's really nice if you can just provide a stack and then it's just working. So that was the first thing we did. And let me check it. Like I can create a new project. And I could create a new workspace, and we just added an R stack here. And it has a specific version and some libraries we need and so on. So that's the platform, that's the runtime Tyler was mentioning, that's predefined and just works. Okay, so I created that, and I also have a project. So I go back to the IDE. That's the actual IDE we have. So far, it's actually just 6 weeks or so we've been working on that. And we accomplished a lot of things already, so which is really a good testament for the extendability of Che. And it was also very nice like that the framework is based on dependency injection. So we have very fine-grained ways to kind of interact with the existing code, override things, change things, which is very important if you build a product, right? You need to care about the last 20% and really kind of tune it in the details. So the first thing I want to show you here is like R is a very interactive programming environment. So basically you do everything in an interactive session in a REPL. So I have one here. It's spawned automatically for me. And I could just say, well, hello DevNation. And it's directly printed to the console. No magic here. I could define a local variable, again with hello. I have an environment view here. And you see, like, it knows the local variable. And then there's a lot of other kind of packages that are installed, and they are all shown. Next up, R is a very kind of visual language in the sense that it has first class support for plots. So I could just plot something here, and then there is a plot view that shows graphics. That's not so nice because I'm not I turn into an R expert these days, but I don't really know a lot of things about data scientists yet. So, but I can do more, and I know maybe, I want to show you the kind of collaboration features we have automatically with Che. That is, imagine you're working on a project, and you have some problem, and for instance, you don't know how to make pretty images. You could just go off and send a link to a friend who knows better, maybe. He pastes the link, and he will see the exact same session, or the URLs are hard to see what's going on here. Okay. So he opens the link, and he sees really the same session, and he knows the trick. There is a kind of a demo you can run through. It's called graphics, and so as you enter, you see it's all event-driven, and every kind of client sees the same stuff. And so, but you can also really work on the same stuff simultaneously. So one could have a comment saying hello, and you see it's not here. And I can say at the same time, hi there in this session, and they are not interfering. So I send it here, and you see still I have my comment here and can send it over. So this is a really nice way to kind of work on the same session, sort things out, and so on. Right. Then, of course, this was all kind of views we added. But then in the heart, there is the language support we needed to build. So there's this editor support. And you see it has kind of highlighting, warnings. It has some sort of content assist and so on. So the basic features are already there. And in the second part of my demo, I want to talk about how we did that. So I go back to my slides and move on. And one thing we've been working on for actually 8 years now is Eclipse XText. Who has heard of that? Wow, that's good I'm here. That's not so many. It has been around for 8 years or so. It's an Eclipse project, and you can think of it as a parser generator that also takes care of everything else that's needed for language support. It does all the runtime stuff. It has a compiler framework in it, and it also has tooling support. So you design a grammar and run a code generator, and you end up with kind of a full-blown language with tooling for Eclipse, for IntelliJ IDEA, and for Orion. That's the current state. It's been used by a lot of kind of companies for all kinds of big products, but also small domain-specific language in individual kind of projects. And of course, we want to have support for Eclipse Che in that, right? And when we got to work on this R IDE and we need to work on the R language implementation, it was very natural for us to go and think, okay, how can we kind of move XText into supporting Eclipse Che? But we didn't want to everyone, like there's many existing XText languages out there, and we just want to make it very easy to have XText language support in Che. So we didn't want to have everyone building Che extensions because they don't need this fine-grained power that framework allows you to do, but just want to have very fast turnarounds and very easy way to just install language support if you have an XText language. So we would go for a generic XText plugin for Che. That was the first idea. But then, like, we already have a lot of code to maintain at Eclipse XText with the other platforms, the other editor platforms. And I don't really want to add more code to that. Also, there are other editors we might want to support in the future. And so that doesn't seem to be the right way to go. And then on the other hand, like IDEs have the same kind of problems from the other side of the fence, so to say. So I talked to Tyler about that. And like we were looking at the landscape of languages, and the languages these days come up with kind of language servers. That is, the compiler can do more than just diagnostics. It can do rename refactoring. It can do code completion and these things. Like TypeScript has that. Then there is Turn.js for JavaScript, a process that does these things. There is OmniSharp, which is a wrapper around this Roslyn.NET compiler. And there's other kind of these servers. And so the idea was like, shouldn't we have like one language server protocol to connect all the editors with all the languages? Wouldn't that be like the ideal world? Then the languages don't need to support like 6, 7, 8 different editor plugins. It's literally like that. If you look at GitHub for some of the languages, then there is like language name /atom, language name -eclipse, and so on. Like, and they have to maintain it. And on the other hand, there's editors, and some of the very popular editors maintain a lot of language-specific code. Eclipse, for instance, and IntelliJ also. And that's not really a good idea. So we looked around, and we figured that the language server protocol that is defined by the VS Code guys fits best. So it's very independent of VS Code, actually. It is just JSON-based protocol. So we went ahead and kind of started building a prototype for Eclipse Che. We, TypeFox, also migrated XText to support that, and we talked to other people to supporting that as well. And so I want to show you what it's looking like now. We did that actually 3 weeks ago or 4, I'm not sure. It's very recent. So we have 2 files here. This is the XText definition. I'm building a very, like, let me show the example first. So back to this Che IDE. Here you see just some file. Can you read that from the back? Or should I can do it like this? That's some domain-specific language I've defined. You can define entities with properties and data types. Very simple, very generic. And then you want to kind of generate code from that, whatever kind of code. So that's kind of the mission here. And I want to have support for that in Che. So I can, like, in 2 months or so, I can just implement that language also in Che and just start it right away. For now, I go back to Eclipse or IntelliJ, and I define a grammar. So this is really very close to Backus-Naur form. I guess most of you have seen something like that at the university. It's very simplified. It does more than just the parsing. It tells the interpreter also how to create an abstract syntax tree and the types and so on. And then this is a template written in Extend. It's a code generator language mostly that translates entities to Java classes. And I just need to have these two things. Then I run a Gradle build, and I get a jar out. And for the time being, that's the way how we install our kind of language support. I upload a file, choose the jar here. In future, it will be a bit fancier, I guess. And then I would need to reload the IDE. And you see, I got syntax coloring, a keyword highlighting here. I got an error marker that it says I cannot see like a type string because I haven't defined it. So I can use code completion in order to define it. And I can also, like XText out of the box supports multi-file, like project workspaces can index them right away. So I have like any number of files here, adding an address, for instance, with a street. And as you see, I can really reference a string here. I can use find references that already works. So I see the string is used here. So that's the stuff we've been able to do so far. Also, like the XText language server is a full kind of compiler running incrementally. So whenever I change stuff, the files get generated from like the generator you saw on the right-hand side. It produces these kind of Java beans. So far we have a street. Oops. Let's add a city, for instance. And so it incrementally updates, right? So that's really cool. And of course, we have the same stuff going on in VS Code. That's the exactly same jar file we run within VS Code now. Actually, with a very similar models also. So we have navigation, we have find references going on here. Hovering works. All right. So that's the status quo of the language server API protocol. We really hope to see more people going into that. A quick kind of overview of how it works technically, the language server protocol, just in case someone wants to build it on the client side or on the server side, build something with it. So there's the tool and the language server talking to each other. The first thing that happens is, like, when you open an editor, the tool sends a did open notification to the language server, so it could open up the buffer and load the information. Then when the user edits, it gets an update. So it's really like a document buffer on the server. Then it kind of incrementally updates the changes and sends back diagnostics for the full workspace. It can do that. And then you can also do, for instance, go to definition. So you would kind of say, like, go to definition. You send a text document information, like it's this file and this line and this column and so on. And it sends you back all the results with the URIs and ranges. So this is basically how all the features that are supported from the language server protocol works. All right. So then that's the list of the currently supporting languages. We have C++, PowerShell, JSON, developed by Microsoft, XText, developed by us, PHP, Haxi. For Java, like, I mean, the Che server should support that very soon. And then Red Hat is working on stuff like based on JDT together with CodeNV. Then we have editors. Of course, VS Code and Eclipse Che. And also, we are hoping to see more for other editors. One thing is for standard old classic Eclipse, have a plugin. It would make a lot of sense because then you have kind of easy support for TypeScript and maybe C# and so on. Also there, the Red Hat Eclipse committers working there together with the community. It's a cool joint effort there. All right, Tyler.
Thank you.
I'm done. Thank you. Any questions regarding XText and the stuff I showed? All right.
Thank you. Okay, so I started off the conversation by saying, hey, how do you provision a workspace without the user having to install any software? And in the demo that I just gave and the demo that Sven gave, we obviously installed the Che server and running it. I was running it as a Docker container. He was running it as a server. So that's obviously some software that you have to install up front. This is where my company CodeEnvy comes in. We make a product which is very similar to Eclipse Che. And we embrace the workspaces identically, but we do two things to them. One, we distribute the workspaces on a scalable infrastructure. And two, we have this automation capability that makes it possible to dynamically construct workspaces on demand based upon the context of the user without the user actually having to install anything. We call this capability a factory. And to give you a demo of that, since I'm on the Eclipse Che website here, and we've got all sorts of different ways to do this. One way is you could just put in your GitHub repo here, and we will then select a default runtime for your workspace and provision it with the contents of that repo. But you can actually extend this a little bit further and provide a lot of policy information, such as should the workspace have a password? Is there any sort of default commands that you want populated into it? Should it have a time of day association with it? You can even do a guided tour that happens after you launch it. So if I go back to that original application where I struggled early on, I can click that, and you need to have an account. So I just log in. I hope this account has enough resources available on it. I click that, and without having known anything else, it's off to the races, and it's provisioning a workspace essentially with a defined stack, the defined set of code, and it's going to launch the Workspace Agent, and it's going to pre-populate it with a set of commands, and even then launch a series of commands after the fact. And you can do things with this, such as find replace. You can do some code swapping. You can identify the user who's clicking on the link and inject in keys or other things that are specific to that. And sure enough, here we go. I didn't have to go through the, create the workspace for me. It's got it all pre-programmed there, and it even went ahead and launched a Maven command here and running. It looks like it's running it on node1.beta.codeenvy.com. You can see that the URL up here is beta.codeenvy.com. It's a little tiny. But that's actually what's going on. And this run command did a Maven spring boot :run, Maven on this complete directory, and it's going to town on that. And it started, and there we go, all that for a hello world. But I didn't have to install anything, right? And then, we make it possible for this infrastructure to install and maintain. And what's interesting is that all the extensions and customizations that work in Che would work in CodeEnvy as well, and we co-release at the same time. So all the releases are always in conjunction, and they never get far apart on that. I'm going to wrap up here. Our big objective in coming and showing this is that we're trying to build community. Community is a big deal for us. Right now, there are 70 contributors on the project, which is really good. That's grown a lot. I think we had like about 30 or so a year ago, so it's come a very long ways. We're spending a lot of our time working on infrastructure level. We're looking for collaboration in a couple of different ways. One, there's a lot more tooling that we want to bring into the system. And so pretty much there's this whole range of experiences that have been built with previous IDEs, and that tooling should be brought into a system like this. Another area is we're doing a lot of work on the lower runtime infrastructure level. So things around container dynamic injection. We're implementing the Docker Compose spec so that you can have a very fluid compose definitions for your workspaces in there. We're getting into things related to how to do network overlays so that developers can define networks and wrap them in. We want to add more programming language servers. There's a lot of room to bring those programming language servers in. And we're working on a public registry, kind of like a Maven repo, but only for language servers so that you can discover them, install them, maintain them without having to do any work in that regard. You can also badge your open source repo. So if you work on open source projects and you badge it with this badge that looks like this, which is a factory, just like we saw, and you give that to your users get free 4 GB workspaces here. And you get as well. So it's in our interest to make sure that these workspaces are widely used and for us to demonstrate the performance and security of those workspaces. So if you want to get into the habit of writing these factories, creating these workspace recipes and sharing them around, we're certainly going to encourage that and help you with that. So I'm going to pause it here. We're very excited by this project. We have a long ways to go. And I'll open up for any possible question that you may have.